In this video, we're going to take a look at the Unit 6 review for geometry, and I have it split into a few parts. So we're going to look at the transformation practice first. Number 1 says to describe the transformation resulting from each of the following rules. So describe it precisely. So when we have this adding and subtracting here, this is going to be a translation. So this will be a translation by directed line segment -4, 1. So you just take as if you were plugging 0, 0 in here, and that's going to take it to the point 0 minus 4, so -4, and then 0 plus 1, so 1. So that's going to be a translation by directed line segment -4, 1. This next one where you multiply them, if you're multiplying by the same number, so here we're multiplying by 2's, so both the x and the y are being multiplied by 2. This is a dilation with center 0, 0 and scale factor of 2. Next one has two different things happening here. So this negative in front of the x actually takes and flips your x values. So if we think about where your x values are, and it makes them opposite. So if we had a positive 3x value, now it's going to be at -3. So that's going to flip this or reflect this over the y-axis. So this will be a reflection over the y-axis, and again, that's because of that negative in front of the x, and a translation by directed segment 0, 6. So then we're also moving up 6 units with this +6 on the y. Part D has a translation by directed segment -2, 0. And it also has a reflection. We see that this y is negative, so and a reflection this time over the x-axis, since the y coordinate is negative. So again, this has the similar idea to this, where now our y coordinates are opposite. So now if we had this y value here of like 2, now it's going to be down at -2. So this is flipping. So this negative is flipping over the x-axis. And then the last one. So this last one does some interesting stuff where now the x and y are in opposite spots. So it flipped the x and y, or it switched the x and y, and it's doing the opposite of the y. So I often don't remember this rule, like I don't have it memorized. So I just take a point, like the point 3, 1, and I apply the rule to see what's happening. So now if I put 3, 1 in here, now what I would get back is the opposite of the y. So remember, I put 3, 1. So the opposite of the y is -1. And then I would have the x coordinate next. So my new point would be the point -1, 3. And so then here's this point. So this one is actually a rotation 90 degrees counterclockwise. So I usually don't remember those rules, and I just make up an example for myself and do it to see where it moved to. But you know that it's going to be a rotation when these x and y's switch places. So when they're not in the same spot anymore. So there's another one that would be like y opposite x. or opposite y, opposite x. So you can get a couple different ones, and that means that it's going to be some type of rotation. Number 2, given triangle ABC on the graph pictured, draw the image of the triangle under this transformation. Label the result as T. So we want to go to the left 4. So we want to move in the x direction 4. And then we want to go plus 1. So up 1. So we want to move all these points 1, 2, 3, 4 to the left and up 1. So there's our new B prime. 1, 2, 3, 4 to the left and up 1. There's A prime. 1, 2, 3, 4 to the left and up 1. So there's C prime. And then they want us to label this as T. And then describe that transformation precisely. So again, this is a translation by directed line segment -4, 1. Or you could say left 4, up 1. Then draw the image under this rotation. XY maps to Y opposite X. And for this one, again, I would look at the actual ordered pairs. So I would write them out. So A is 1, 1. B is the 0.2, -1. And C is the 0.30. So now I would do that transformation, which says put the Y coordinate first. Okay, so take this Y coordinate and put it first. So now you're going to have 3 different points, one starting at 1, one starting at -1, and one starting at 0. And then it says take the opposite of the X. So now this X is 1, the opposite of 1 is -1. This X is 2, the opposite of that is -2. This X is 3, the opposite of that is -3. And then you'll plot these new points. So we'll go to 1, -1, -1, -2, and then 0, -3. And then we can connect those. And they want us to label this one as R. Then the last one is doing a dilation. And so this one is having us multiply the X and Y each by 2. So I'll just take these original coordinates that I wrote out right here again, and now we'll just double them. So 2, 2, 4, -2, and then 6, 0. So we're just taking and multiplying all of those. And then plot the points. So 2, 2, 4, -2, and then 0, 6. Connect those. And label that one as S. Number 3, for each rule, describe whether the transformation is a rigid motion, a dilation, or neither. So rigid motions have just pluses or minuses in them, and no multiplication. Dilations have multiplication by the same number. And then neither would have multiplication by a different number. So this first one is going to be neither, because it's got multiplication and addition. So neither. This next one is a dilation because it's got by a scale factor of 2. So these are the same multiplication here. This next one is rigid. It's a combination of a translation and a reflection. D is just a translation, so this one is rigid. E is a translation as well, so this one is rigid. And then F is just a reflection, so that one is rigid as well. All right, then we're going to look at doing the next part of the review, which is the line practice. So number 1 asks, what's the general equation used to write the equation of a line when you know the line's slope and just a random point on the line? So this is called point slope form. And point slope form, you do y minus the y coordinate of your point equals the slope times x minus the x coordinate of your point. And so your m is here, your slope is here. Then you've got the y minus the y coordinate of your point, and you can call it y1. You can also call it k. And then you've got x minus the x coordinate, which again you can call x1 or you can call h. So a lot of times in this we call it hk. So it just means any point that is on your line. So that point is hk. So what do you know about the slopes of the lines if they are parallel? And that would be that they are the same slope. And for perpendicular lines, they're going to be opposite reciprocal slopes. So that means opposite sign plus or minus, and then the flip of the fraction. Number 3, the graph of y equals negative 4x plus 2 is translated by this rule. What is the slope of the translated line? Translated lines means it doesn't change the steepness of the line. It just moves it. So if this is our line, we're just going to be moving it down to the left 3 and up 2. So no matter where I translate this line to, the slope stays the same. So the slope is still going to be negative 4. Number 4, match each line with the perpendicular line. So let's make sure that we have the slope of each of these. So we see the slope here for part C is 2/3. But the others, we need to do a little bit of work to find them. So in part A, you subtract the y's. So 19 minus 4 goes on top. And then subtract the x's. So 9 minus 12 is negative 3. So this slope is negative 5 for part A. For part B, you would solve this and get it into slope intercept form, which means solved for y. So we'll subtract 2x from both sides. So we get negative 5y equals negative 2x with a plus 10. Then we would divide everything by negative 5. And you'd get y equals negative over negative is a positive 2/5 x. And then 10 divided by negative 5 is negative 2. So this one has a slope of 2/5 for part B. So then let's take a look here. We can see in these that the slope here is 1/5. And we're matching to the perpendicular slope. So we want opposite reciprocals. So positive 1/5 is the reciprocal of negative 5. So this one goes with A. We can also see that number 3 has a slope of negative 2/5. Negative 5/2. So that's the reciprocal of positive 2/5. So this one is B. So that means this one must be C. And we could subtract these again. 4 minus 1 is 3. And then 1 minus 3 is negative 2. So that is the flip and the opposite of 2/3. Number 5, select all equations that are parallel to this line. And remember, parallel means same slope. So this slope here is negative 2/5. So we're looking for negative 2/5 as our slope. So positive 2/5 would not be good. Negative 2/5 is good. Negative 2/5 is good. And then positive 5/2 would not be good. And then we can solve this one. So we would be subtracting the 10x over, and then we'd be dividing by 5. So that's kind of a shortcut to subtract or do the opposite in front of the x divided by the number in front of the y. So this is going to give us a slope of -2, so E would not be parallel. Number 6, select all equations whose graphs are perpendicular to this. So this means the opposite and the reciprocal of -3/5. So the perpendicular slope to this would be positive 5/3. So we're looking for positive 5/3. So let's rule out a couple here. So this one's -3/5 for part B, so that's bad. This one's negative 5/3 for part C, so that's bad. Positive 5/3, that's what we want, so D is good. 10/3 for this one, so that's not right. -3/5 for this one, so that's not right. So then let's look at part A. So we would subtract the 3x, and then we would end up dividing by -5. Negative over negative is positive 3/5, so that one's not good either. Number 7, write the equation of a line that passes through each of these. So let me just write out the general form of an equation again. So we have y minus our y coordinate equals our slope times x minus the x coordinate. Remembering that the slope goes here. We've got our y value of our point, and then we've got our x value of our point here. So write equation of a line that passes through this point. So our x coordinate is -1, so that's going to plug in here and be x plus 1. Our y coordinate is 2, so we're going to do y minus the 2. And then the slope is parallel to this one. So we want the same slope. So this one's slope is 3. So, or sorry, -3. So we want to plug in -3. So then this would be the equation of our line. So if I just write that not in color, it'd be y minus 2 equals -3 times x plus 1. So same idea for this one. So we're going to have y minus the y coordinate equals the slope times x minus the x coordinate. And we want our equation to go through the point that is the origin. So our origin is our original point, and that's the point 0, 0. So then we're going to have y minus 0. We're going to have x minus 0. And then we just need the slope perpendicular to this one. So here's this slope. The perpendicular slope would be the opposite, so negative, and the flip of this, so -1/5 would go in here. And then if we just simplify this a little bit, it would just be y equals -1/5 x. Number 9, write the equation of a line parallel to this one and passes through this point. So I'll just write this out. Y minus the y coordinate equals the slope times x minus the x coordinate. Okay, our x coordinate is -6. So -6 turns that to a +6. Our y coordinate is 4. So it'll be y minus 4. And then we need parallel, so we need this same slope. And this slope is 2/3, so the parallel slope is also 2/3. So then that would be our equation. So y minus 4 equals 2/3 times x plus 6. Number 10, use the line shown to write these equations. So write the equation of the actual line. And so we can see this line crosses through the y-axis at 7. So we can use our slope-intercept form for this. And slope-intercept is y equals mx plus b, with b being the y-intercept. So this is our b, exactly where it crosses the y-axis. Then we just need to figure out our slope. And so then you want to find another point that it goes through, and then just calculate the rise over the run. So this one is 1 and 2, and this one is going downward. So this is a slope of negative 1/2. So then we can write this equation is y equals negative 1/2 x and then plus 7. You can also, pick any point you want and put it into point slope form like we did on the last one as well. Then you want to write the equation of any line perpendicular to this one. So it doesn't matter what you choose. The only thing that will matter is the slope. So when you write your equation of your line, your slope needs to be the opposite reciprocal of negative 1/2. So for the perpendicular slope, the slope is going to be positive 2. And then for parallel, it needs to be negative 1/2. The rest of it doesn't matter. So you can write any equation you want. So long as this says 2x, and then it can be plus or minus anything else right here. And then for parallel, it needs to be y equals negative 1/2 x, and then anything else. So this could be y equals 2x plus 3. It could be plus 32. It could be minus 32. This could be minus 87. This could be plus 87. It could be 871. Okay, as long as the slope is 2, it's going to be perpendicular. And as long as the slope is negative 1/2, it's going to be parallel. All right, now we're going to look at the circle portion of the review. So what is the general equation used to write an equation of a circle with a given center? And so I'm just going to write out a center here. So center being HK, and then a radius R. So the general equation here is going to be x minus our x coordinate squared of our center plus y minus the y coordinate squared of our center equals our radius squared. So it's going to be x minus h squared plus y minus k squared equals our radius squared. So then what is the center and radius of this equation right here? So this number that's subtracted from x here is our x coordinate of our center. And the number subtracted from y here is our center. So remember, if this is positive, we subtracted a negative 7. So this is actually negative 7 for your y coordinate. So this would be your center. It's always opposite of what it looks. And then we need to know what number here was squared. So 36 is 6 squared, so the radius is 6. Number 3, write the equation of the circle. So let me get this written out. So x minus our x coordinate squared plus y minus the y coordinate squared equals the radius squared. So remember that we'll take this x coordinate of the center, has to be of the center, and plug it in here. So x minus negative 3 squared, and then y minus the 2. So y minus the 2 squared, and then equals our radius, which is 5 squared. And then you can leave it just like that. You can also actually square the radius. So we can put x plus 3 squared plus y minus 2 squared equals 25 if you wanted. But either of those is fine. All right, number 4, write each expression as a square of a binomial. So we want to figure out what number multiplied by itself gives us 36 and then adds to that negative 12. And so the square root of 36 is 6. And then we need it to be negative so that it gets us this negative 12. And so let me just do that off to the side here for this first one just to show you. So x times x is x squared. X times -6 is -6x. Then -6 times x is -6x. And -6 times -6 is +36. So we're looking for this number, this -6, -6 adds us to our -12, and it multiplies to that 36. So for this one, we're going to have y, and then the square root of 16 is 4, and then we need them both to be positive to get us +8 in the middle. And then square root of 64 is 8. So 8 times 8 gives us 64, and then we need -8 plus -8 to get us that -16 in the middle. So now we just want to fill in the blank with what number would go here to give us a perfect square. So remember, we needed 2 of these to get here. Okay, so we had 2 -2's, and then remember we have to square it. So then this would be -2 times -2, which is 4. So you're taking that middle number and dividing it by 2. Okay, that's getting us to this -1, and then squaring it gets us to +1. So -18 divided by 2 tells us that that number is -9, and then we square it to get that end number. So remember that that had been x minus 6 on that last one, so that gave us 2 -6x's, and then the -6 times -6 gave us that +36 at the end. So it's this middle number divided by 2, and then we square it. Number 6, find the center and radius of the circle with this given equation. So for this, we need to use what we just did. So you'll see this part, okay, from the last one in part A. And so we want to put in that, and actually let me draw this in black first. So we want to come up with the number that we would add in here that would make this a perfect square binomial. Okay, so what number are we going to add right here? And then same for the y part. What number did we add to make that a perfect square binomial? And then we're going to have to do that to both sides to keep our equation balanced. And so again, you just did this on the last problem. But the number that went here was -4 divided by 2, which is -2 squared, which is 4. Now, when you add it to this side, you have to add it to this side as well. Then same for the y. So -2 divided by 2 was -1, squared was +1. Add to both sides. So now you're going to factor this, okay, and do it like we did here where we're making them perfect square binomials. So this one is going to be x minus 2 squared. And then this one is going to be y minus 1 squared, because -1 times -1 is 1. And then 20 plus 4 plus 1 is 25. So then that helps you get the center and the radius. So the center here is 2 for the x. Remember, opposite of what it looks like. And then 1 for the y. And then our radius is the number that squared gives us 25. So the radius is 5. Then we want to graph the circle. So we'll plot this point 2, 1. Okay, so 2, 1 is right here. And then you would count using the radius. So I would go up 5, down 5, to the right 5, and to the left 5. And then just draw the best circle that you can. If you have a compass, you could certainly use that. Otherwise, just draw the best circle that you can. I'm going to use my compass drawer. So then there's the circle. Now for part B, it says for each point, determine if it's on the circle. And you can just look here for some of them, like 4, 0 is obviously not on the circle. So if we go to the point 4, 0, it's obviously not on the circle. And the way that you check it is by plugging it into this equation. So we would do x, let me write this out. So we would be plugging these values in. So instead of x, we're going to be plugging in the x value. So x minus 2 squared plus y minus 1 squared. And then that should equal 25. So this is what we're going to do is plug these all in here. So for this point, our x is 4 and our y is 0. So then 4 minus 2, this is 2, squared gives us 4. 0 minus 1 is negative 1, squared is 1. 4 plus 1 is 5, which does not equal 25, so this is not on the circle. And then we'll just keep doing that with these other ones. So we'll be doing negative 3 minus 2 squared plus 3 minus 1 squared and see if that equals 25. So I just plugged these points, negative 3, 3 into our equation. And so negative 3 minus 2 is negative 5. And then we're going to square that. And 3 minus 1 is 2 squared. So negative 5 squared is 25. And 2 squared is 4. That's 29. So this one is not on our circle. And then the last one, negative 2 minus 2 squared. And then negative 2 minus 1 squared should equal 25 if it's on our circle. Again, we just plugged in this negative 2 into our equation. So negative 2 minus 2 is negative 4. Squared is 16. Negative 2 minus 1 is negative 3 squared, which is 9. 16 plus 9 equals 25, which is good. So this one is on our circle. All right, then finally we have parabola practice for this next part. So in general, what is the equation used for a parabola using the focus and the directrix? So we have y minus the directrix squared, okay? And so then this is going to be your directrix. And then the focus is an ordered pair. So the directrix is a line. The focus is a point. So I'm just going to call this x of the focus and y of the focus. Actually, let me switch colors here. So y of the focus and x of the focus. And so then we have y minus the directrix squared equals x minus the x coordinate of the focus squared plus y minus the y coordinate of the focus squared. So this will be the x of the focus and this will be the y of the focus. So write the equation that states xy is the same distance from 0, 5 as it is from this line. And that's the definition of a parabola. So a parabola is the set of all points that are equidistant from some directrix and focus. And so what this is asking us to do is write the equation of the line with this focus and this directrix. So we're going to do y minus the directrix squared, and the directrix is this negative 3, so we'll plug in negative 3. And then that will equal x minus the x coordinate of our focus plus y minus the y coordinate of our focus. And the x coordinate of our focus is 0. And the y coordinate of our focus is 5. So y minus 5. So then that would be our equation. And then similar thing for this next one, except for now it's just telling us that the directrix is the x-axis. So you need to know that that means that the y coordinate is 0. So on the x-axis, the y coordinate is 0. So we'll take and we'll do y minus the directrix, which in this case is 0. And then x minus the x coordinate of the focus plus y minus the y coordinate of the focus. X coordinate of the focus is 4, so just x minus 4. And then y coordinate of the focus is -3, so -3 we would plug in there. Number 4, a parabola has a focus of 3, -2, and a directrix of y equals 2. The point A -8 is on the parabola. How far is the point from the focus? So for this one, I'm just going to sketch this out so we can, look at this. So we've got the point 3, -2 here. And then the directrix is at y equals 2. So that's going to be here. And then we have this point something -8. Okay, so we don't know what the a value is. It doesn't really matter. But we do know that the y value here is at -8. So this down here, this point is on this line somewhere at -8. So how far is the point from the focus? How far is this point from the focus? And it is on our parabola. So that means that we've got this parabola that goes through here, right? And the point A -8 is on here somewhere. And this orange parabola is the same distance from the directrix and the focus. Okay, so any point on here is the same distance from the focus as it is from the directrix. So let's just say our point is here, A -8. The distance here, okay, this distance is equal to this distance. And we know -8 up to 2 is a distance of 10. Okay, so -8 to 2, those are 10 apart. So then we know that this point is 10 away from here as well. So the point is 10 away from the directrix, so it's 10 away from the focus. Number 5, write the equation for the parabola with each of the given features. So this first one gives us the focus and then says the directrix is the x-axis. Remember, that's saying y equals 0. So we'll do y minus the directrix squared equals x minus the x coordinate squared plus y minus the y coordinate squared. And that's going to happen for each of these. So let me just copy this down here. And then we've got in this first one, the focus given to us. So we've got this 0.52, and in this next one, we have the point -23. Let me just get these colors on here. And then we've got 0.7 for that last one. And then in this next one, we had the directrix given to us in each of these next ones. Okay, so then let's plug our stuff in. So we do y minus the directrix. So in this case, that's going to be y minus 0. And then x minus the x coordinate, which is 5. So y minus 5. Or sorry, x minus 5. And then y minus the y coordinate, which is 2. Next one, again, y minus the y coordinate of the directrix. So y minus 7. Then we'll do x minus -2. That was the x coordinate of the focus. And then y minus 3, the y coordinate. For this last one, y minus -1. And then x minus 0. and y minus 7. Number 6, a parabola has a focus of -1, 6 and a directrix of y equals 4. Determine whether each point below is on the parabola. Explain your reasoning. So you can write out the equation here and plug these in if you would like to. You can also kind of look at how far the point is from the focus, if it's nice, and see if that's the same distance from the vertex, from the directrix. I'm just going to write out the equation here. So y minus the directrix, so y minus 4 squared should equal x minus the x coordinate, so x plus 1 squared, and then plus y minus the y coordinate, so y minus 6 squared. So these two things should be equal. So when we subtract when we do x plus 1 and y minus 6 squared, okay, that should equal the y coordinate minus 4 squared. So let's just plug these in here. So we're going to be doing the y coordinate, which is 5, minus 4 squared. That should equal the x coordinate, -1 plus 1 squared, and then plus, the y coordinate, which is 5, minus 6 squared. So 5 minus 4 is 1. So we've got 1 squared, and that should equal -1 plus 1 is 0. So 0 squared. And 5 minus 6 is -1 squared. So this says 1 equals 1. So this one is good. And then we're just going to do this for the rest of them. So we're going to take the y coordinate minus 4 squared, the x plus 1. So we're just plugging these in to the equation up above and seeing if they work out. So our y coordinate is 7. So 7 minus 4. And then our x coordinate is 1. So we're doing x plus 1 squared, and then y minus 6, and the y was 7. And then we're just seeing if these equal. So 7 minus 4 is 3 squared. 1 plus 1 is 2, so we'll do 2 squared. And then 7 minus 6 is 1 squared. So we have 9 equals 4 plus 1, and that is false. So this is for number 2. So that was false, so that didn't work. So then we'll plug in for this next one. So we'll plug in the y coordinate, which is 9. And then the x coordinate, which is 3 plus 1. And then the y coordinate, 9 minus 6. So 9 minus 4 is 5. 3 plus 1 is 4. 9 minus 6 is 3. So we get 25, and then we have 16 plus 9, and 16 plus 9 is 25. So C is also on the parabola. All right, so in this last one, we're just going to do equation practice, or we're just going to practice with the equations and deciding if the point 2, -3 is on the graph of each of these. So this one's in point slope form, so you might notice that this is the ordered pair. Okay, so x minus 2, so the 2 is your x, and 3 would be your y, so 2, 3 would be on there. And as a line, that means 2, -3 cannot be on there. You can also plug it in. So you could plug in 3 in for y and 2 in for x. 3 minus 3 is 0. -3 in. So -3 minus 3 is -6. All right, in this last one, we're going to be working with all the types of equations and just trying to see what we know. So this one is select all equations for which this point is on the graph. Now there's going to be different ways you can do this. One of them is to just plug this in for x and this in for y into all of them. If both sides of the equations are equal, then the point is on the equation. You may also notice some, like in part A, that this is in point slope form. So that means that one of the points on this graph is the point 2, because that's what we're subtracting from the x, and then 3. So 2, 3 is on this line. If 2, 3 is on the line, 2, negative 3 cannot be, because then it wouldn't be a line. So you might notice that. Okay, then the other thing, like I said, again, you can just plug these in. So you could do negative 3 minus 3 and 2 minus 2. Negative 3 minus 3 is negative 6. 2 minus 2 is 0, and see that those don't equal. Part B, we would plug them in. So we'd be doing 4 times 2, which is 8, and then plus negative 3. So minus 3 or plus negative 3. 8 minus 3 is 5. So we get 5 equals 5. So this is on this line. Y is negative 3. X is 2. So we have negative 3 equals 5 times 2, which is 10, minus 13. So we have negative 3 equals negative 3. That means that point is on the equation. Part D is a circle centered at 0, 0. So we can just plug this in. So 2 squared is 4. Negative 3 squared is positive 9. 4 plus 9 is 13. So 13 equals 13. That is on our circle. Part E, we see as a circle equation. And we see that the center of this one is 2, negative 3. So that's the center is the point we're looking at. So that one's definitely not going to be on there because that's going to be in the center of our circle. Whoops. So 2, negative 3. So this point would be set in the center of this circle. So definitely not going to be on it. You can also plug it in. 2 minus 2 would be 0. Negative 3 minus a negative 3 would be 0 also. So you get 0 plus 0 does not equal 25. Then next one, this one's a parabola. So we could plug it in here. So plug in negative 3 for y. So negative 3 equals, and then 2 minus 2 is 0 squared plus 3. So we're getting negative 3 equals 3. So that's not on there. And then the final one, negative 3 equals 2 squared, which is 4 minus 7. And 4 minus 7 is negative 3. So that one is on that parabola.